Hello, we are discussing about GATE 2002 ECE paper, and this question is related to digital circuits. Look at the circuit diagram given. The inputs to a digital circuit shown in figure are the external signals A, B and C, and A bar, B bar, C bar are not available. That is, complement of the inputs are not available readily, and plus 5 volts power supply, which is treating as logic 1, and the ground, which is logic 0, are readily available. And the output of the expression is given: x is equal to a bar b plus a bar b bar c bar. Now you are going to do first one. Write down the output function in its canonical SOP and POS forms. And second one is, you are going to implement the circuit using only two 2-to-1 multiplexers. Okay, the 2-to-1 multiplexer is shown. Like that, you are going to choose two 2-to-1 multiplexers, okay, to implement that function. So we will see how to write the canonical SOP and POS forms for the given expression. Later we will see how to implement that one using multiplexers. Okay, so the x value is going to be given as x is equal to a bar b plus a bar b bar c bar. It was given. This is x, and if you want to write it in the canonical SOP form, canonical SOP, it is also called as standard SOP, where each and every product term must be implemented with all variables. That is nothing but every product term must be a min term. Min term is a product term in which all variables must be present either in complemented or uncomplemented version. So now if you are looking at this one, first term is a bar b. This is a product term, it is not a min term. So that you must convert this into min term, and a bar b bar c bar, that is the second term, which is min term, because in this one all three variables are going to be present. But in the first product term only two variables are present, c is missing. So we can implement that one, a bar b into c plus c bar plus a bar b bar c bar. Everything we are writing. C plus c bar is nothing but 1. 1 into something is nothing but something. Value will not change whenever you are multiplying with 1. So we are assuming that one, a bar into 1, that 1 can be written as c plus c bar. So now it will be consisting of x is equal to a bar b c plus a bar b c bar plus a bar b bar c bar. If you want to write it as canonical SOP form, at that time we must write it as sigma m of, like this you will write. Okay, so in SOP form, complement is nothing but 0, true value is nothing but 1. So you can think in this way: a bar bc is nothing but 0 1 1, and this is 1 0 1, and it is 0 0 0. So 0 1 1 is nothing but 3, and 1 0 1 is 5, 0 0 0 is 0. So first we will write all these three things in ascending order. So sigma m of 0 comma 3 comma 5. This is canonical SOP form. Canonical SOP form of given function. And you can get the same expression by going through the product of sums also. By that time you can represent the same thing. Product of sums is nothing but multiplication of max terms. So whichever the terms are considered for the min terms, that will not be considered, and except them whatever the other terms, that has to be considered for the max terms. Because you are going with three variables is nothing but 8 possibilities you will get, 2 power 3, which is nothing but 8 possibilities. Out of 8 possibilities, 3 you have considered for the SOP form. By considering other 5, you can get the POS form. What are that one? 1 2 4 6 7. These are nothing but, okay, these are called as max terms. So this is canonical SOP form, and in this one, 1 implies nothing but, you can write 1 implies nothing but 0 0 1, 2 is nothing but 0 1 0, 4 is 1 0 0, 6 is 1 1 0, 7 is 1 1 1. Okay, and in POS form, 0 implies nothing but uncomplemented, 1 is nothing but complemented. So we can write like this: 0 0 1 is nothing but now a plus b plus c bar multiplied by second 0 1 0 0 1 0 a plus b bar plus c. Next 1 0 0 0 2 3 0 2 3 0 3. So a bar plus b bar plus c, and this is plus, and again we are going with this is 1 0 0. 1 is nothing but complement, and 0 implies nothing but true values plus c, and 6 is nothing but a bar plus b bar plus c, and 7 is nothing but a bar plus b bar plus c bar. This is what, if you are going with product of sums, this is what canonical POS form. It is going to be called as canonical POS form. Canonical POS form. Now this is what the first part of the given question, and second part. First part is this one, and second part is nothing but this. Second part, you are going to implement the given expression by using two 2 to 1 multiplexers. The given expression is this one. Okay, the given expression is x is equal to a bar b plus a bar b bar c bar. Okay, so first of all you minimize this one. So whenever you are minimizing, you can make it as a bar common, so that it will be b plus b bar c bar, and then b plus b bar c bar can be written b plus b bar into b plus c bar. So by that time b plus b bar is equal to 1, so that you can write it as a bar multiplied by b plus c bar. So a bar into b plus c bar is going to be the expression you are going to get. This is what the minimized expression for x. Now you are going to realize this one with the help of 2 to 1 multiplexers. Only 2 to 1 multiplexers you are going to implement this one. Okay. So first we will implement b plus c bar, then we will go for the a bar into b plus c bar. So first we will implement b plus c bar using one 2 to 1 multiplexer, and the output of that one is going to be used for the second 2 to 1 multiplexer to get the entire x expression. Okay, so we are now concentrating on b plus c bar. B plus c bar, implementation of b plus c bar. B plus c bar, let us assume it is f is equal to b plus c bar. So if you are going to write the truth table for this one, it is going to be looks like this one. B plus c bar can be written as 0 0 0 1 1 0 1 1. You can write this one for the expression as, you will get b whenever you are going for these two things. Okay, b is going to be, you are getting whenever you are adding bc bar plus bc. If you add those two minterms, at that time you will get b. And c bar is going to be, you are getting whenever b bar c bar plus bc bar, that is nothing but this one and this one. If you add, you will get c bar, and you don't get this expression 1 0 1 1. So f can be written as sigma m of, okay, 0 2 3. You can write this one. F is equal to, that implies nothing but b plus c bar. So observe this one. So look at, concentrate on. Okay, now concentrate on, this is nothing but m0, m1, m2, m3, that is minterms. So from minterms m1 and m3, from minterms m1 and m3, okay, what we can observe is nothing but from minterms m1 and m3, c is equal to 1. So whenever c is equal to 1, that is c is equal to 1 is common. For m1 and m3, c is equal to 1, that is common. So whenever c is equal to 1 at that time, that is for two variable expression, one variable is going to be kept constant. So by that time output should depend on other variable. Since c is kept constant, output should depend on b. Okay, f is a function of two variables b and c. Out of two variables, if you keep one variable constant, output definitely depends on other variable. So if c is equal to 1, compare f and b. That is nothing but how much it is depending on b. So whenever f is equal c is equal to 1, f is equal to 0. Since b is equal to 0, whenever c is equal to 1, if b is equal to 1, you will get f is equal to 1. That implies nothing but simply you are getting the expression as f is equal to b. Whenever c is equal to 1, f is equal to b you are getting, and again from the other things m0 and m2. From m0 and m2, okay, c is going to be 0 is common. Whenever c is equal to 0, f should depend on b. If b is equal to 0, f is equal to 1. If b is equal to 1 also, f is equal to 1. So whenever c is equal to 0, f is not depending on b. F will be always 1 irrespective of b value. So we can write like this, f is equal to 1. So now we will implement this one using a 2 to 1 multiplexer. That 2 to 1 multiplexer is nothing but this is a 2 to 1 multiplexer which will be having a select line and two inputs. This is what output line, and this one we are assuming it as f. Okay, this is 2 to 1 and select line is nothing but s. S can take either 0 value or 1 value. So here we are going with c. Select line is connected with c. So whenever c is equal to 0, above line is going to be that 0th line is selected. Okay, and whenever 1 is going to be selected, at that time first line is selected. So we will compare like this. Whenever c is equal to 0, f is equal to 1. So you connect over here, logic 1 over here, logic 1. Whenever c is equal to 0, f is equal to 1, and whenever c is equal to 1, f is equal to b. So this is what the implementation of function f, that is b plus c bar, using 2 to 1 multiplexer. Now the truth table, from the truth table we have identified the relation between f and b whenever c is constant, and that c we are taken it as select line, and select line can take 0 or 1. Whenever it is taking 0, f is equal to 1. Whenever the select line c is equal to 1, f is equal to b. That is what we have connected. So that this now satisfies the equation b plus c bar. Now you must use this one and another 2 to 1 multiplexer to get the entire expression a bar into b plus c bar. Now this is what our interested. Now how to multiply with a bar? Okay, so for that one we are going with one more 2 to 1 multiplexer, and this is what select line, and which will be having two inputs, one output. So now connect a for this select line. A can take 0. 0 implies nothing but a bar. 1 implies nothing but a. So we must multiply a bar with b plus c bar. So connect f to this one, f to this one. So f implies nothing but b plus c bar. Now it is connected as input for 0th line. 0th line is selected whenever a is equal to 0. That implies nothing but a bar. And you must get only this expression, you should not get the other expression. There is no expression in the outputs with a into something. So multiply this one with logic 0. So now this is what the final expression x. X is equal to a bar into b plus c bar plus a into 0. That implies nothing but x is equal to a bar into b plus c bar. Okay, which is nothing but a bar b plus a bar b bar c bar. So this is what the expression for this. So a bar, b bar and c bar. So this is how to implement with 2 to 1 multiplexers. Okay, thank you.